Everybody, welcome back to another fun and exciting pre-calculus class. In today's lesson, we'll be jumping into chapter number 14. We are getting so close, hang in there. And chapter number 14 is talking about polar coordinates. What are polar coordinates? Well, you've heard of Cartesian plane, right? Coordinates, x and y coordinates. Well, this is another way to do graphing. So let's go ahead and look down here at the book. We're in chapter number 14 on page 274. I love this quote right here. It is his work, not unto us, but to thy name, O Lord, be all the praise. So, in other words, this is quoting a Bible verse right here, but then he says, it is his work. What is his work? Well, Samuel Morse was a mathematician, scientist, and so the work that he was doing, he's saying, it's not my work. This discovery of these different things, this when I'm doing this mathematics, it's not my work. So as you're doing your mathematics, as you're discovering new things to you, it's not about you. Okay, it's not about you at all. It is like what the Bible says, not unto us, but unto thy name, O Lord. Everything we do is for his glory and his honor. And hopefully, as you finish out this book, you will do that. Not take the personal glory for it, but give him all the honor and praise for what you've accomplished in this book. Chapter number 14, Polar Coordinates. Introduction to polar coordinates. Graphing by rectangular coordinates is only one of the many graphing systems possible. Rectangular coordinates are the Cartesian plane, are the x and the y. Okay. Another system is called polar coordinates. So polar coordinates, this is a way to do things on poles. What's a pole? Think of the Earth here. Think of like the North Pole and the South Pole, that the Earth is a ball, okay? It's spinning, rotating on those poles. So what we're going to have is we're going to have the same concept of kind of graphing on a ball, if you will. Down here it says that in general, polar coordinates are listed as, and it looks like a P, but that's not a P, that's called a rho theta. So let's look at this example over here, figure 14a. We have 0.22. That is on a rectangular. So when we're graphing using coordinate points, this would be 2 on the x and 2 on the y. And you can see that it creates a 45-degree angle. Now, when we're dealing with polar points, notice that our theta is our angle. So whatever angle this creates right here, we're going to use that for our polar point. Okay. Now, what is this rho? This rho is, you could call it a couple different things. This rho is your hypotenuse, and in trigonometry, we call that the r. The hypotenuse is r. What does r stand for? It stands for radius. So this rho, you could think of it as radius. Rho, radius. I know it looks like a P, but it's really an R. That's a rho. That's for radius. So you take the radius of your line, and you take the angle down here, your theta, and that's going to be your point. So the first point, your x point, is going to be the radius. The theta point, or your y point, is going to be how much of a rotation there is of that radius. Now, this does not really work on regular graph paper. Notice it says polar graph paper consists of a series of circles concentric at the point called a pole. You need to get some polar paper. Now, you can't just like go to Walmart and buy polar graph paper. They don't really have that. So what you do is you can go online and you can search for polar graph paper, and you can print out a bunch. You could also use some online resources. I haven't found a great one that I really, really love. I'll be using GeoGebra, and then I'll be using another one called Delta Math in this lesson. But I haven't found one that I'm just like, oh, I love this, because it just works really, really well. So I would suggest printing off, go to find a PDF or something of polar graph paper, print it off, and then use that. So where we had 0, 0, or the origin, that is going to be called the pole. The center point is going to be called the pole. And it's like then the rho is going to be how long that extends away from that center point, from the pole. It's called a radius or a radius vector. So the polar axis is kind of like your x-axis, And then the theta doesn't really, the rotation doesn't really have an axis because it's a circular pattern. You'll see what I mean in just a second. In fact, let me show you real quick. This is polar graph paper. And so this is the only axis that you have. Well, you do have kind of a, an axis here at 90 degrees, 180, and then 270. Now these are all in radians, right? So that's at 0 degrees. Pi over 2 is 90. Pi is 180. 3 pi over 2 is 270. You need to get familiar with radians. I know we've used radians a little bit in the class, but for the most part, at this point, you're going to be using radians. I know the book is giving them to you in degrees, but a lot of times on the polar paper, you're going to see it done in radians. So you really need to be able to transfer back and forth in between radians and degrees pretty seamlessly at this point. All right, so let's jump back over here and let's go to the next page, page number 275. The first one they want you to graph is at 630 degrees. So what we would do is we would come over here, and the way that these work is like every one of these circles is 1 on the x. All right, so we're going to go, there's one circle. So we're going to go 1, there's 2, 3, 4. You can see these number here on the x. And the same thing would be true over here going negative. All right, so these can go negative. Notice this is -3. So you'd go, if you're going this way, you're going -1, -2, -3. Okay, so you have negatives going one way, positives going the other way. So basically anything on this side of the circle, these are negative points. And anything on this side of the circle, these are going to be positive points. Okay, so if we're going this way, positive. If we're going this way, negative. So the first point here is a 6. So we want to go over here as +6. So we want to go here 1, 2, 3, 4, 5, 6. Here we are at the 6th ring, if you will, the 6th loop on the paper. And you can set them for however much you want. This one, this is actually setting it so each one would be half. So there's a 1.5, there's a 2, there's a 2.5, there's a 3, 3.5, and so on. You can set it up however you want it on your graph paper, but basically you need to label it, and this one is labeled the 6. So this is the one that we're dealing with right here, the 6th ring around it. Okay, so we go up here and say 630. So what we want to do is go to the 6th ring, and we want to go up here to 30 degrees. There's 30 degrees on the 6th ring. If we were on the 2nd ring, we would go right here because that's 30 degrees on the 2nd ring. Okay, but we're on 630, so there's our point. The next one, 2, 195. So we're going to go over here to the 2nd ring. There's 2, and then we're going to go all the way over here to 195. Now, you might say, but I thought you said that this was negative over here. Well, it is and it isn't. Okay, and here's why. If we go 2 positive, we would go 2 positive, and then we would go 195 all the way over to this point. You'll see what I mean in just a second when we do the negative one. So the next one is negative. So 4, -30. So we're going to go 4. Now this is going to be 4 on this ring right here, 4 positive. -30, we're going to go down 30. So we're going from 0, and we're going to subtract 30 from 360 right here, and we're going to get our 330. Okay, so just do what it tells you to do. 430 and then 4 -30 are two different things. 4 and -4 are two different things. So just do what it tells you to do on each one. Here's another negative one. 3, -180. So we're going to the 3. Here it is. Now we're going -180. Now here's the crazy thing. -180, +180 are the same thing because they're both the same distance. So if we're going -180, we're going around here, and there's your -180. 3, 180. 3 +180 would be the exact same point. So 3, 180 and 3, -180 are exactly the same point. It just gave us 3, -180. All right. Now we get one where we have the negative, the first number is negative. So here's -475. Now this one gets a little bit tricky. So we're going to go over here, -4. So instead of +4, we're going -4. 1, 2, 3, 4. And notice it's +75. So we're going to go over here to -4. Okay. And then we're going to add 75 to 180. 180 plus 75 equals 265. So we're going to come down here to 265. We're right here. There's our negative 475. It's going to take a little bit of math to do this, but you work your way around. And then let's do this last one where we have negative 3, negative 330. All right, so we're out here on this third ring, and then we're going to rotate it in the negative direction. You got to remember, negative direction is going clockwise. So we're going to rotate it around basically 330 degrees and come all the way back around. And there's our point, negative 3, negative 330. All right, let's practice these a little bit more. We'll go over here to this delta math screen, and let's plot the polar coordinate for point 3 and then 5 pi 4. So we're going to come over here 3. So here's 1, 2, 3 rings out. So we'll go 3 rings out. There we go. And now we have to go, this is positive, so it's positive, positive. And we're going to go all the way around this ring right here until we get to our 5 pi over 4. Right back there. There we go. And then we'll submit our answer just to kind of check it, and we have it right. So let's go for a new problem. All right, so let's do this problem. This one gives us negative, negative. Now look, they've taken away our radians, so they're not going to allow us to cheat over here anymore and see the radians. Hopefully you know that pi over 6 is 30 degrees, so this is going to be negative 30. So here's what we need to do. We need to go negative 5. So there's 1, 2, 3, 4, 5 on the negative. And then we are going to go 30 degrees negative. So negative is clockwise. So it would be right about there. Okay, 30 degrees in. We'll submit that answer. We'll check it. And there we go. Let me also show you GeoGebra real quick. So here is another way to kind of plot. I don't love this as much, but basically here's our R, which is our row. So you put your row at whatever it is. So let's grab one of these from the book. Let's grab this one. I don't think we did this one. Negative 4, 330. So if we go negative 4, 330, we'll go negative 4. 1, 2, 3, 4. All right, so there we are right there in the fourth ring. And then we're going to put our theta at negative 330. So we'll spin this into, and notice it's changing here. So negative 330 is actually going to be positive 30. All right, so we rotate it right in there and we go plot. And then we can clear this out. We'll pull these back to 0. And we can see our point got plotted right there. So I don't love the GeoGebra one, but it's better than nothing, and it's digital, so it can, let you know where the points are going to be. But I would suggest you get your own little polar coordinate point thing, piece of paper, run those off, and then you can put those on there. All right, last thing that I want to do here, let's go to the next page. Actually, let's go to the bottom of that same page, 275. Notice it says here, in either graphing system, coordinates correspond to only one point. In other words, when you have a coordinate, that's all there is to it. It's at that point. But in rectangular graphing, any points has one and only one pair of coordinates. But in polar graphing, we've already kind of seen this. You can have different points that are the same. 230, positive 2, positive 30, is the same. It corresponds with 2, negative 330. Think about that. If I wrap it negative 330, it's going to land in the exact same spot. Also, if I go to 390, so in other words, if I wrap it all the way around 360, and then I wrap it another 30, I'm going to land right back on 230. So depending on how many times you spin this thing around, you could actually have infinite number of points landing back on the same coordinate point. So just spinning around in circles. And that's because the 360 just keeps looping you back. So negative 360 loops you back, positive 360 loops you back. And if you're going negative on the row, the first coordinate, the R, that can put you back on the same spot as well. So let's go ahead and do some of those on the next page. All right, so here's our problem. We'll finish up with this. 6 30 degrees, and it wants you to do all this to it. Let's go over here to my computer and do this over here. So here we go, 6 30 degrees. We want to find two polar coordinates that meet these conditions. P is greater than 0, so it's going to be positive, and theta is also greater than 0. So for 630, here's what we would have to do. The 6 can't change because the 6 has to be positive, so the 6 can't change. So we're going to have 6, but this is going to be able to change. How do we do this? Add it to 360, so it would be 6, 390. That would be 1. And then another one would be 6, and then we could add it to another 360. And so 360 plus 360 is 720. 720 plus 30 would be 750. We could keep going with that. We could add another 360, and that would give us another point that matches, but we don't need 2, we just need 2. All right, let's go ahead and do the next one. Find two polar coordinates where rho is greater than 0, but the theta is less than 0. So we're going to have 6, and then we're going to have a negative theta. All right, and so if we're at 30, all we do is subtract our 360. So 360 minus 30 is 330. So that would give us a negative 330. All right, here we go. And then our next one would be 6 comma negative, and we would just subtract that from 720. 720 and then 30, and that is going to give us a negative 690 would be our other one, negative 690. And again, we could keep going with that, but we don't need to because it tells us to only find 2. The next one, two polar coordinates where the rho now is going to be negative. So now we have a negative 6. Now this one gets a little bit tricky. So think about this. If we're going to the negative 6, remember we want it to land on the 30. We want it to land on 630. So if we kind of draw that out, we want it to, and we have different number, but let's just use this outer one. We want it to land on 30 degrees. So now if we're going negative 6, how do we get it to come all the way back? Okay, because we're going in the positive direction. This is positive angles. So how do we get it to go all the way back? So we need to go 180, and that will get us back to 0. So 180 plus 30 would be what? 210. So this would be 210. And then we would add 360 to that to spin it again. So 360 plus 210 is going to give us 570. So negative 6, 570 would be another one. Now the last one is negative negative. I'll use this same one that we just used, but now we're going to go again. So we're going, this is 0, but we're going to the negative side, right? So this is 180. So if we're spinning this on the negative side, so there's negative 6, and now we're going this way. We're not going all the way back a full 180, are we? Okay, we're stopping short of the 180. We're stopping 30 degrees short of 180. So we would say 180 minus 30 on this one, and that's going to give us 150. So this one would be negative 6, 150, negative 150, sorry. And then negative 6, and then the next one we would wrap again a negative 360. So we're going to keep going 360. So we could add those, it'd be negative negative, and that's going to give us 510, negative 510. All right, so there's your answers to that. Not extremely complicated, but it does take a little bit of mental processing there just to kind of figure out which one you're going to be in, which kind of movement you're making on those coordinate points. All right, hope you understood that. I know that's kind of confusing, and some of those systems were a little bit wonky there because they didn't work exactly right. I don't love the online sources that I found, but use your just print a PDF of that and use that and go around those and get your points on there based on what you're supposed to do. So if it's negative, go negative. If it's positive, go positive. Make sure you remember which way you go. Remember that on a circle, when you're dealing with degrees, positive is going counterclockwise and negative is going clockwise. And so that's a little bit counterintuitive, but just remember that. Be thinking through that. Make sure you remember your radians. If you need to, use your calculator to go back and forth between radians and degrees and just work through this. All right, that's all I've got for you. Hope you learned something there. We'll see you later. Have a good one. Bye-bye.